How's everyone doing? Welcome to RoboLacyTech. Today we're going to see how to build a gear reducer for a full rotation MG996R servo motor. I designed this for a 5 degree of freedom robot I'm working on, which I'll be sharing on the channel soon. To make it, I based it on a reducer I had previously made for a NEMA 17 motor, but I made a few changes to adapt it for the MG996R. You can find the STL files and the full list of materials on my cults page. There you can download everything needed to 3D print it. Besides the printed parts, you'll need some screws and bearings, which you can get from JLCMC. JLCMC is the ideal solution for both small and medium-sized businesses, as well as for independent creators working on their own projects. They offer a complete supply chain for automation components, catering to those who need just a few units for prototypes, as well as those looking for large quantities for mass production. Thanks to their integrated production line, JLCMC guarantees superior quality while maintaining highly competitive prices in the industry. Their commitment is to provide cost-effective and high-performance solutions, designed to help more people and businesses bring their ideas to life. And that's not all. Very soon, they will be launching a new industrial service, affordable, fully customizable, and specially designed for makers, creators, and small businesses looking for more accessible options without sacrificing quality. If you're interested, you can find more details and special offers on their website. In fact, if you register for the first time, you'll receive monthly coupons worth over $60, including a $19 coupon for your first purchase. You can find the direct link in the description for more information. Thanks to JLCMC for supporting this video. This gearbox is designed to work with a continuous rotation servo motor. If we were using a standard servo, the output angle would be very limited. With a 5-to-1 gear reduction, a 180-degree rotation on the motor would only result in 36 degrees at the output, which isn't very useful for most robotic applications. Using a continuous rotation servo avoids that limitation, but we lose the internal encoder, so we can't read the motor's position directly. I considered using an external rotary encoder, but it takes up too much space for this particular robot. I still haven't decided how I'll handle this, so if you have any ideas, feel free to leave them in the comments. You can download this model for free from my cults page. If you want the editable step file to make your own changes, it's available on Patreon. You'll also get access to all my other designs with a subscription. Let me know in the comments what other projects you'd like to see on the channel. See you in the next video.